Alright, so good night guys. I'm going to talk about what I did today. So last time I stopped here and then I realized that it will just be expanding this, this, which would give us FG, and because the problem says this, we can substitute this here and we get to the result. For the other one, well, it's the same thing. I didn't have to expand this here, but it helped me think about a solution. So yeah. This was exercise 5A and 5B. Now for exercise 6, wait, I think I didn't do 6. Yeah, for exercise 7, yeah, prove the rules for these things. So yeah, basically did this. Now exercise 8, yeah, basically the other way around for this one. And yeah, I just expanded this till I got something very separated, that I could say this must equal this. Now exercise 10, if f belongs to S3, show that f elevated to 6 equals identity. So what I did, because 3 is a small number, I just wrote all the functions that there could be. So we know that there could be set1, set2, set3, and we could have 3 functions. Wait, yeah, we could have 3 functions. Now I'm not sure if, I think there are more than 3 now, but I'm not sure. I'm kind of tired also, so I will recheck if this is correct tomorrow. So what I did was, well, function 1 will be identity, so this returns this returns this, and this returns to here. And second function would be this. This function will give this with this function with this input will return this. With this input will return this, and with this input will return that. The other one would be in jumps of 2. So yeah, and I just said for the first case we just needed one step to get identity, so this would be f elevated to 6 equals identity. Second case we needed 3, so 1, 2. For this one we only needed 2, so this should be a 2 here and a 3 there. For the last one we needed 3 steps, so 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3, so yeah, 3 elevated to 2, which would give us the identity. Now exercise 11. Can you find a positive integer m such that f elevated to m equals a identity for all f belonging to S4? So I did this my old way, which would make more sense to me, I guess. Right now at this moment it doesn't really make much sense, but I think it's because I kind of fried my brain in the last like 10 minutes or so. Yeah, so I did this. How I got these numbers was by checking the functions and how many steps for each function I would have to take to get to the identity. I could only do this because there were 4 elements. If there were more, I probably wouldn't have done that. So I found the max common multiple between 4, 2, 1 and 4, which would give me 4. Then I tried m equals 4 factorial, which would give us 24, which is a lot bigger than 4. And just for 12, isn't this like straight up better solution? Wait, what did I write here? Okay. So yeah, I thought that this was clearly superior, but then I realized that I don't know a way to calculate this quickly and just have to do this manually. So yeah, here this way we have a guarantee and a simple way that this will work instead of doing all this manual work. And bonus, I forgot why this works. Like, I read some post, I understood it, but when I got to exercise 13, it stopped making sense. So yeah, I guess I'm too tired, and tomorrow I will recheck it. For exercise 12, basically says the same as 11, but this time it's SN instead of S4. And I just said from exercise 11 we can see that there is a number m that will give us for all functions in Sn the identity. So I didn't prove for one specific, I proved for all, which isn't very efficient, but I said take this one and it will work for any. For exercise 14 is basically doing this but for Sn, and I'm not getting it. The why, like, the why would I get 4 factorial? So yeah, that's it guys, thanks for watching, goodbye.